Hello everyone. So in this video we will try to cover structures and pointers, which are very important topics. And what are structures? Structures are basically user defined data types which can store many variables even of different data types under a single name. So what we had seen with arrays is that we could save the variables with same data type in under a single name, but in structure we can save with different data types. So an example of a structure is given here. So this is a structure which can store a roll number which is in int, the name which is in format of a string, and even the CG which is in format of a float. So this is how the structure is defined, and we need to create, this is the data type which we have defined, and here ABC is a variable of that data type struct student, and we have defined it as an array. So here ABC is an array of struct student data type. Like if there were integer arrays, there were character arrays, this is struct student type array. So in this, to take input, we can use this kind of statement to access each variable inside the structure. We use the dot operator, as we can see here. The dot operator gives access to the individual variables inside ABC of I. So I is the index of the array, and inside each cell of the array we can say that there are three variables. So inside each cell the roll number, name, and CG are stored. So that is how it works. That is how the structure helps us to store data systematically. Next we cover pointers. So the main important things to keep in mind for pointers are the meanings of star and ampersand symbol. So what star basically means is value at, and ampersand means address of. So address is the memory location at which a variable is stored. So suppose there is a variable n, it has a value 100 and it has an address which would be somewhat like this, and this address is what we can store in a pointer. So whenever so a pointer basically refers to the variable which is stored at that particular address. So as you can see, we have declared a variable n, we have taken it as input, and then we can see the other use of the notation star is while declaring a pointer type variable. So here p is a pointer type variable, so we have used star here, and we have assigned it to the value ampersand n. So ampersand means address of. So here address of n. So that would be this here huge number. So this would be assigned into p. Now int star p means the pointer would be having an address which would be pointing to a variable which would be of integer data type. Similarly, we can have char star and other float star pointers which would represent the data type of the variable which the pointer is pointing to. So to summarize, the star notation is used while declaring a pointer type variable, and it also means value at, and the ampersand symbol is used to refer to address of. Now another important thing here is that arrays are implicitly pointers. So whenever we declare an array like this, ARR by default represents the address of the 0th location of the array. Similarly, char star s can represent a string, which is basically a character type array. And another important thing here is pointer arithmetic. So if we increment pointers, it increments as multiple of size of the type of that pointer. So suppose if we increment a by 1, and suppose a equal to 200, and then if we do this step and then again print a, then we would see that a is printed as something like 204 because it adds a size of int to it. Similarly, if we would have added 2, the value printed would have been a plus 2 into size of int. So this is how pointer arithmetic basically works. And another thing to keep in mind is that assigning a value directly to a pointer is invalid. You need to assign an address of some variable to a pointer, otherwise it would be invalid. Now let us see a few example programs with pointers. So here is a simple program to swap two numbers using pointers. So here we can see that the addresses of A and B are passed to swap function, and the swap function has int star x and int star y as the parameters, which are integer type pointers. So the addresses get copied in here, and after that int t is a temporary variable, so t gets the value of x. Remember we said that star means value of, so t stores the value of x. The value at x is assigned with the value at y, and the value at y is assigned to the value with the value t. So this is how the two numbers are swapped. And note that these changes would also uh, be implemented in the actual variables and not only in these local variables, because these the addresses have been passed and there is a reference created. So whatever change happens in those addresses would be reflected everywhere. So on printing these, we would see that the values of A and B are swapped. Now let's recall in the video on strings, we had seen these functions like strcat, which concatenates two strings. So let's see how we implement it using pointers and what the actual definition is. So char star s1 is a string, is the first string. Constant char star s2 is the second string. We have made it constant. That means we cannot change the value in the s2. So we basically declare a pointer p and assign it with s1. So remember here s1 is a pointer and it is basically a string. So string is a character type array, which is basically represent another representation of a pointer. So we traverse along the string s1 till the value at p does not become null, and we increment p. Then we start with s2 and make the value at p plus plus equal to value at s2 plus plus. So we basically, from the point when s1 ends, we start copying the values at s2 till the value at s2 becomes null. So that way we have copied the string s2 after the string s1 and the concatenation is successful. Next we have the strcpy function, which copies one string into another. So similar to the strcat function, we have a constant char s2 and char star s1. So here we perform a similar operation and we directly apply star p plus plus equal to star s2 plus plus here, and this copies the string into s1. And here is the strcmp function, which is basically quite useful for comparing two strings lexicographically. So here we traverse till s1 is not null and s2 is equal to not equal to null, and we increment s1 and s2. So basically these follow pointer arithmetic, as you would remember. So whenever we get that the value at s1 is greater than s2, we return 1, which is a positive value, which means that s1 is comes later in the lexicographical order than s2. In the reverse condition, we return -1, and after that we check if s1 has reached null earlier or s2 has reached null earlier. So this means the length of the strings are different. So suppose if a string was a b c and the second string was a b c d, so in this case the two strings would have the same values till c, and then string s1 would reach null and s2 would still not reach null. So whenever s1 is not equal to null, this continues, and both the conditions must be satisfied for this for loop to continue. But whenever s1 becomes null we come out of the loop and check these two conditions. So we find that s2 is not equal to null, value at s2 is not equal to null, so we return -1. And if none of these conditions is satisfied, we return 0, which means the two strings would have been equal in that case. Thank you.